All right, just one more. A spherical weather balloon is inflated at the rate of 8 cubic feet per minute. At what rate is the surface area of the balloon changing when the radius of the balloon is 4 feet? We'll get a picture rocking in here. So it is spherical, and the inflation rate is 8 cubic feet per minute. This means that dv dt is going to be positive 8. At what rate is the surface area of the balloon changing? That means that we want the ds dt. Well, all right, this is actually going to involve a couple steps. This static relationship here is that the surface area of the sphere is 4 pi r squared. And then if we take the derivative of that, ds dt is going to be equal to 4 pi times 2r times dr dt. But here's the thing. We actually, although we do know the radius, we know the radius is 4 feet, we do not know dr dt. And notice that actually there's a couple of other things missing. We never needed to use the fact that dv dt was 8. This gives you a hint as to what's missing. So we'll write another static relationship having to do not with the surface area this time, but with the volume, in hopes that this will allow us to go and get the information that we need, namely what dr dt is. The volume of a sphere in general is 4/3 pi r cubed. If we take the derivative of that, that's going to be dv dt equals 4/3 times pi times 3r squared times dr dt. Here is the link between them, because see how we know everything here? We know dv dt, we know r, and so we can use this to solve for dr dt. So let me put these in quickly. dv dt is 8. 4/3 and 3 can cancel. So this really becomes 4 pi r squared. R at the instant we're interested in is 4 squared times r prime. That means that r prime is going to be equal to, oh geez, this is 8 over 4 times 16 is 64 pi. So this will be 1/8 pi. Okay, so this I can use for my r prime. Now I can go back to this line and say I know that ds dt is going to be equal to 4 pi times 2r. Well, that's 8 because 2 times 4 is 8. And now I magically know what dr dt is. At this moment, it is 1/8 pi. And actually, a lot of things cancel here. The 8s cancel, the pi's cancel, and we get 1/4. And do always put units here. Cubic feet per minute. Feet was the radius of the balloon. So since this is surface area, it will be square feet. And because it's a derivative, you need to put it per minute. So 1/4 of a square foot per minute. And there you have it.